Hi, and welcome back to Tech Talk. I'm Ken Mingus, Executive Editor at Computer World. I'm here today with Juliette Beauchamp and InfoWorld Serdar Yegelap to talk about artificial intelligence and machine learning. We've got Serdar back for more of an interesting discussion. A quick reminder, if you're watching us live, we're streaming on our YouTube channel. Please subscribe if you like what you see. And we're also streaming on the Computer World LinkedIn page. Please follow the page if you want to keep track of what we're up to for future episodes. Serdar, welcome back.
Thanks again. Hi.
Yeah, thanks for being here. We actually have some questions from the last show that some people had submitted, so I thought I would throw those your way and see if we can get some answers for the viewers.
Sure thing.
Okay. Question number one from Sujay. Which frameworks or tech languages can be used to build web-based machine learning models?
Well, the easy point of entry here is the Python language, since that's the one that's currently dominating the field of working with machine learning. I should point out that Python itself is not what is actually being used to construct machine learning models. It's more of a wrapper for the libraries that are written in C or C++ that do all the actual heavy lifting.
Okay.
But it makes the job far easier. So getting started with that and getting started with the libraries that are associated with Python for machine learning, like TensorFlow, those are always a great start. I should point out that the Go language is actually starting to also show a lot of progress in this space, although not quite to the same extent. Again, also the Julia language, they're both coming up in this space with many of the same kind of conveniences. But Python has been successful in big part because it is so convenient to work with. And so that's always been a very good low barrier of entry for getting started with this kind of work.
Mm-hmm. Yeah, I was going to, in fact, just to sort of follow up on that, what is it about these languages that makes them better or more ideal for coding around ML?
Well, one of the things about working with something like machine learning is that a lot of the heavy lifting, again, is done in a separate library, which is written in a much more powerful language than Python itself is. But working directly with those libraries in the languages that they're written in is something of a headache. And Python takes away a lot of that headache by abstracting away a lot of the behaviors that you would normally have to deal with, like memory management or the handling of objects. So you can deliver very high-level instructions to the library for how to handle a machine learning workflow. And that way, a lot of the work that you would normally have to do yourself is pushed out of the way, and you can concentrate on things like keeping your data clean or making sure that the whole pipeline is functioning correctly.
Got it. Okay, cool. That's really useful information. Mm-hmm. Second question from Mode is how can one get started with artificial intelligence and machine learning? What coding languages should they learn? You've sort of already touched on that one.
Python.
Yeah. Python.
Right. Python and Go, and also the Julia language, which is starting to become more popular. It was specifically developed for math and statistics and scientific computing. And is designed sort of to be a best of all worlds type of thing, and that it's supposed to be as easy as to use as Python, and also as fast as C++ in many respects. But it's still very young. It's still only a 1 point something release at this point, but it's getting a lot of attention for how it addresses these problems. So I would pay attention to where Julia is going in this space in the future. But Python is never a bad place to start with it. And on another level, the how to go about doing it generally. Get started with some toy projects. One of the beautiful things about Python is that you can set up something on a computer on your own and get started right away with models that you can download, from the internet publicly, and that way you can get used to the workflow that's involved, where you acquire a data set, you make it clean, you bring it into conformance, you train a model around it, and then you deploy it, even if only on a toy web server, and you serve predictions from it. The last part in particular can be the hardest. The deployment, the whole pipeline, assembling the pipeline for the deployment can be trickiest. And because there isn't even really one, doctrinaire way to do it. There are ways to do it, but there isn't, it's not like there's a de facto standard that has been established. There's simply a set of best practices that you have to try to hew to as closely as you can. So having some local practice for doing this is always a good thing. If you want to try doing this stuff in the cloud, where you have access to much bigger data sets or much better training hardware, Databricks, for instance, has ML models and ML training systems that you can use in the cloud in an experimental way, where you can work with them a little bit and then throw them away when you're done, or you can purchase a full plan, upgrade from the free one, and do real work in earnest there. So
Okay.
play with it. That's my best suggestion.
That's always a good way to start. Just
Yeah.
a quick reminder, if you're tuning in, we're talking to Serdar from InfoWorld about artificial intelligence and machine learning, answering some earlier questions, and then he's going to get into some more details about what's coming up. What's the third question we got, Julia?
Yeah, our third question is from Shaw, and they asked, what data analysis skills are needed for using/running AI? So beyond knowing Python, I guess.
Right. I mean, obviously, you need to have some skill with programming, with wrangling, a piece of software into the pipeline, and to think logically about problems. But the big thing that I would start with is if you don't have any knowledge of statistics, then start there. You want to pick up a course in statistics and understand things like p-values and correlations, and what these things mean and what they don't mean. Because if you don't, you're going to be foundering. And you want to do that also to separate your math skills from your programming skills, because the two don't always have a lot of overlap. Programming is often a lot more about logical thinking and about designing a project, about being able to break a problem down to lots of little steps. And math is totally separate from that. So if you separate those two and you focus on statistics as its own learning experience, that's going to pay off enormously further on.
As I remember
Yeah.
statistics from college, so much for my AI ML coding career. That's already over with. Not a big fan of
I wish I
statistics.
could come up with something.
Yeah, no,
for
I couldn't do that.
statistics.
Good. All right, that's really good advice. So it's really important to have.
Yeah.
So we wanted to talk a little bit about moving forward now, before we see if there's any new questions about how organizations are really starting to use AI and ML. We had someone on last week who dealing with robotics, and I was
Yeah.
surprised to find out when Keith Shaw was here that machine learning is becoming more of a component of some of the robotics that are
Yeah.
being developed.
Yeah, but even just going beyond robotics, there's so many other practical use cases that are not as easy to physically see as a robot. So what are some other
That's always the problem,
examples?
isn't it?
Yeah.
No, it's true. I mean, it's so easy to look at a robot and say, obviously they're using artificial intelligence or machine learning, but it's a little more difficult to look at how people are running like data analysis using AI. So what are some examples that you've seen that
Yeah.
enterprises are using?
That can be tough. It's
Yeah.
it's always easy to point to something like a self-driving car because
Yeah.
it's so glamorous.
So
Right.
true.
It's easy to
Yeah.
see, as you say.
Yeah.
Yeah, and so many of the real benefits of this sort of thing are not glamorous and in your face.
Mhm.
They're a little, pardon the term, nerdier. They're a lot more out of the way. What it boils down to is that the biggest benefits come from being able to take data and recognize patterns in it that give you insight that you didn't have before. It's not necessarily about predicting what's going to happen. It's about getting insight into what is happening right now. So this could be, for instance, fraud detection. This is actually one of the most common uses of this kind of pattern detection I see is, if somebody suddenly makes a purchase from a geographic place that they have never been to before, that's a
Mhm.
possible flag for fraud. And you have an AI ML system that will take bits of data like that and correlate them and then generate a report and say, there's a high likelihood that this person's account has been broken into, is being used for fraudulent activity. And it's other things in the same vein. For instance, customer segmentation, figuring out what bucket a customer is likely to fall into if they buy certain kinds of things or if they engage with certain subsections of your site. And because these things are not very obvious, because they tend to be much more business oriented, they're a lot harder for somebody to look at and wrap their heads around. But that's where the real value is, because they drive revenue.
Mhm. That's a really interesting point that you made, that there's applications of AI ML that aren't for predicting, for dealing with what's going on right now. I like that point. And
Yeah.
Mhm.
There was a report that I was actually sent by Forrester. The title of it was "Shatter the 7 Myths of Machine Learning." And one of the things they said in there specifically that correlates with this is machine learning really isn't about predicting the future. It's
Mhm.
it's at its best when the future looks like the past, as they put it. In other words, you're not trying to necessarily predict what's going to happen. You're trying to get insight into what happened or what's going on right now. And
Right.
if those things are going to continue more or less unabated, then there will be some predictive value there. But it's best to not assume that they will have absolute predictive value. Otherwise, you fall into the trap of assuming that everything that you've been doing up until now is what you can continue to do, or what you should do things differently because the machine says so.
Right. Is this?
Right.
I'm just wondering. Is this one of the reasons that it seems like there's a lot of AI ML use that seems to be creeping into security? Because
Yeah.
trying to
It's
find
always been
patterns.
useful there.
Yeah.
It's always been useful there in that respect, where you'll have some kind of pattern detection. And only recently they started to advertise it more explicitly as AI and ML, because those are buzzwords and they sell. And at its core, a lot of these things are not necessarily about the really sophisticated forms of AI and ML, like deep learning. They can just be a simple Bayesian algorithm. But yeah, that's a big part of why security software has started to make more noise about using these things, because it's a perfect use case for them. You'll have hundreds of thousands of user behaviors, and you want to be able to pull the one needle out of that haystack that looks like somebody trying to break into the system. How do you do that? You can't do that by pulling through it manually. You have to have some way to sift.
Right.
And so this gives you a way to sift.
Right, yeah, flagging something that would otherwise take an incomprehensible amount of time for just
Right.
even
to find
a
that,
group
as you
of
say,
people.
the needle in the haystack.
Yeah.
Exactly.
Yeah, this is the other pattern that I see a lot, is where you have the machine basically being trained to serve as your co-pilot or to ride shotgun with you, not to take over what you're doing, but to augment it. We were talking about self-driving cars before, and I thought the real win here is not going to be that we'll have a car that drives itself, but that you'll have a co-pilot that will never fall asleep on you, that will always be able to tell you, oh, somebody's about to cross in front of you, or you're backing up, there's somebody to your left that looks like a pedestrian, watch out. That's really useful. And it's useful in the most immediate way. It's not something that's going to take another 5 or 10 years to dope out. It's already useful right now. We can already do that.
And I like that. That's a really good way, I think, of looking at it, and to sort of distill it down to people who maybe are interested and are maybe getting into Python, and they're interested in becoming AI and ML developers. But when you first hear AI ML, it seems so daunting.
Oh yeah.
But when you apply it to something like that, it makes a lot of sense, and it makes it a lot easier to understand just to either the layperson or the beginner.
Right.
Yeah, I mean, if you want to build something specific, one of the pieces of advice I give to people who want to get into software development generally is find some problem that's close to you and work on solutions to that problem that involve programming. And it's the same thing with ML or AI. Find something that's relatively close to you, doesn't even have to be very big, and look for a way to apply machine learning to that. Again, it doesn't even have to be in a huge way, just in a way that makes it incrementally easier. And then as you begin to understand how that works, you can widen the scope of it a little bit. The people who work at Tesla or what have you, they have the benefit of throwing hundreds of people and billions of dollars at a problem and having these huge ambitions. The individual lay developer does not have that advantage. They have to focus on the tiny things, but the tiny things may prove to be much more immediately useful than a skunkworks project that burns through billions of bucks and doesn't produce anything.
Got it. We should probably take a quick pause and see if we have any questions or comments. I have a question for Serdar, but before I move on.
We have lots of questions.
Oh, well,
all
let's
right.
let them
So
and let them go.
people are
Jackpot.
asking about use cases. So here's one, kind of philosophical maybe. How can AI progress our daily life?
Ooh, that's open-ended.
Yeah.
How's it going to make life better for us, Serdar?
Well, I've always gone with the idea that, like I said, it will serve as a co-pilot, and that it will be something that will flag the things that will sometimes slip past us. And that's not always the easiest thing to embed into our lives. I mean, right now we have things like smart devices in the home, and I've always found them to be not very useful, because they don't really seem to be introducing new things. They're not really very new. They're just taking something that already existed and automating it, not always automating it in a way that's terribly useful. If I want to turn the lights off in a room, I can turn the lights off in a room perfectly well myself. So I would really want to see things that are not just extensions of the obvious, automating what we already do. I would like to see things that are more like, genuine problems that we have that have not yet been touched in any way by automation. That's much harder.
Got it.
And then people are asking about the use of AI for education, auto mechanics, and manufacturing. If you have any insight into that.
Those are really broad fields.
It's everywhere.
Yeah. I actually follow a blogger, a fellow from Canada who does a lot of blogging about education and about the impact of technology in education. And whenever he speaks about AI generally, he always seems, again, to speak of it in an auxiliary role, that it's not something where you're going to be using it to replace a teacher grading papers, but rather where you would be using it to get better insight into, say, how students are performing over the course of several years in a given course, or it's not a way to get rid of the teacher, but a way to make his job easier, or to give him insights that he would never be able to have before, that would allow him to do new things with his job that it was simply not possible, because the time that would have been taken for him to get that insight would have been so consuming. And for things like auto mechanics and auto repair, one of the things that I can think of off the top of my head is things like diagnostics.
Mm-hmm.
And the other day I had my car in the shop because I had a punctured tire. I ran over a nail, and I said, well, that's a very easy, obvious thing. But what if you have something that's not so obvious? It's the same way with medicine. If a patient comes in and they have a collection of symptoms that seem like they could be a fungal infection, but may in fact be something else, and you've got this AI assistant that has gathered millions of medical records from across decades and can provide you with more, ways to narrow things down in ways you haven't thought of before. That's beautiful.
Mm-hmm.
Yeah, it's interesting. It seems like so much that AI and ML is related to scale, the ability to take in a huge amount of information and data that no human being could possibly go through, distill it down, and then find the anachronism there, and then figure out what's going on, and then maybe come up with a solution for it.
Absolutely.
I actually do have a question for you, Serdar. When it comes to this, especially in the case of medicine where you have this hyper-personal data about people that is also often protected, at least here in the United States, by HIPAA, how do you have enterprises going about collecting this data fairly and legally in a way that still maintains people's privacy?
That's a really tough one. A lot of the work that I've seen as to where this could go revolves around the idea of taking the data and operating on it as anonymously as possible.
Mm-hmm.
Like, for instance, one of the more out there suggestions that I've seen that is actually not quite as out there anymore over the last year or so is what's called homomorphic encryption, where you take a set of data, you encrypt it, and then instead of decrypting it to perform operations on it, you perform operations on it while it is still encrypted. So you never have to actually see the original data in order to work with it. I guess what I'm trying to say is there are plenty of technical solutions, both that are developing and that already exist to the problem. But the real problem is always going to be a social one. That you need to have strong laws like HIPAA to protect personal privacy, and you need also to have a sensibility among the people who develop these solutions that personal privacy has to be paramount. That, I think, is one of the real shortcomings, that we don't necessarily have a culture of consciousness about personal privacy in the development of software as a whole, and that definitely extends to the way that we would start using AI and ML.
Yeah, don't you think that's sort of related to the fact too that people don't realize how much of privacy is it's easy to give it away, excuse me, without intending it. And it's interesting, that sort of touches on one of the things we talked about the last time you were here, which is sort of the ethics around coding and AI and machine learning, and making sure that the people who are writing the code for this stuff have in mind, ethical situations.
And that extends to everything.
Right, that's true. Yeah, I mean, are we seeing anything more around that right now, or is it just?
I'm certainly seeing a little bit more open discussion about it. Like the other day when I went to one of Google's products for machine learning in the cloud, there were a number of call out paragraphs in the documentation that were specifically aimed at the user, saying, make sure that the data that you are supplying is as free of bias as possible, and will have as positive an impact as possible on the people you're trying to serve with it. I said, a year ago I wouldn't have seen anything like this, and now they're at least making an attempt to bring the subject up in the actual documentation for the software that's being used to build these solutions. That's a nice step forward. It's not the absolute, it's not the only step, but it's nice that there's more casual consciousness about it, and that it's filtering into all of these different aspects of it, not just the usage of it, but the construction of it.
Sure. I mean, the AI has to be built by humans, and humans have an inherent bias, so it's good to be conscious of that bias when you're building something that is going to be widely applicable.
Yeah,
good point.
and that's why you need multiple parties to check each other's
Yeah.
biases.
Of course.
Good point. Do we have more questions, Michelle?
We do. Let's do a few about careers. So somebody's
Sure.
considering making a career into AI and ML. Is that a good decision?
That's like saying, should I have a career in medicine? You know, it's very open-ended. It's not a bad idea, but you have to keep in mind what is going to be involved. You know, first, as I mentioned earlier, you're going to need to have a solid grounding in statistics and in math and in software development.
Mm-hmm.
And then second, you're going to have to figure out, you know, an actual project that you want to aim at. I'm not really enamored of the idea of just becoming a general purpose AI or ML developer in the same way that somebody is not necessarily just a generic software developer. People have a specialization. They'll specialize in, you know, full stack, or they'll specialize in databases, or they will specialize in, you know, software that's designed to protect endpoints or what have you. You know, they will find a specific problem to work on. And you can start by being a generalist. You can start by getting a, you know, a general acquaintance with it. But it's always best to narrow down as you go and find something specific that you can apply yourself to and to build solutions for.
Yeah, somebody was asking about if you needed to be a programmer or if non-programmers can do it, but it sounds like you should have programming skills.
We're getting to a point where it's actually becoming easier to use some of these solutions without necessarily having full-blown programming chops. You know, if you're using Python and you don't really know very much, you can stick pieces together and you can achieve some fairly basic results. But you're always going to be constrained by the limits of the pieces that you are given to work with.
Sure.
And if you're not capable of developing your own pieces on the back end that match or exceed the pieces that you're given, then you're always going to be at the mercy of whatever toolkit you're using. The point of using these toolkits is if you want to solve an immediate problem, that's great. You know, that's what they're for. But for your own progression, eventually you have to learn how to transcend just the Lego bricks. You want to learn how to basically, you know, start distilling your own bricks, lack of any better metaphor.
Do you
I don't
know
know
of
if that
any,
really works as a metaphor, but you get the idea.
Yep.
Do you know of any online courses that people could look into?
There's tons of them, and the bad news is that it can be very difficult to wade through and figure out which ones are actually decent. Khan Academy and Udemy usually have pretty good stuff. I confess that I have not plowed through the vast majority of them. Those two are simply the two that tend to have the best reputation associated with them. It's not a bad idea to start trying them out and then abandon them if you feel that things are just going too slowly or not being explained clearly enough.
Okay. Sounds fair.
Great.
Great.
Before we let you go, any other thoughts about where things are going this year? Since it's January, it's still 2020
Yeah, we're
early.
still-
And it's still
It's still a-
January.
It's still January.
Yeah.
You know, we're just into the new year, so. anything-
Yeah, and I get the impression that there is definitely a sobering of the way that AI is being approached. It's no longer being seen as a magic solution. Everything is no longer being seen as this black box out of which miracles can come. That it's a very specific tool for a very specific set of problems. And that means that it doesn't mean that people are going to stop trying to do moonshots. You know, I don't think that the air has completely gone out of, you know, the self-driving car idea. I just think that people are starting to regard the basic idea as being less important, really, than fixing a great many other things that aren't necessarily visible problems. You know, the problems of climate change, the problems of mass migration, the problems of the political economy of human rights, as someone once put it. Those are all things that involve tons of data. And those are all things that I think would be very amenable to being examined with AI and ML, and that could be used to generate real solutions with, instead of just figuring out how to do the same things that much more, you know, efficiently or automatically.
Yeah, that's awesome. Yeah, I agree.
Great. Well, thank you so much, Serdar.
Thank you.
Really
yeah, thanks,
appreciate
sir.
it.
They're always enlightening, and we have to have you back.
Seriously.
We'll keep this
Yeah.
going.
Definitely. Thanks once again for having me. I always really enjoy it.
Thank you.
Yeah. Thank you. And thank you all so much for watching this episode of Tech Talk. If you liked this video and you're watching on YouTube, be sure to give it a thumbs up and subscribe to our channel. And if you're over on the Computer World LinkedIn page, also give it a thumbs up and follow the Computer World LinkedIn page. There
Got
we
it.
go. That's all the words.
You got it.
Thank you so much again, and we'll see you
Thanks,
next
everybody.
time.